Okay, common ion effect. Okay, the common ion effect is the shift in an ionic equilibrium caused by the addition of a solute. Okay, that is common ion that take part in the equilibrium. Okay, all right. So what is common ion? Okay, what is common ion? So before we could we will be able to understand the effect of common ion. So you should know what is common ion first. Okay, so what is common ion? So common ion is actually same ion. Okay, so dia nak tahu what is the effect if we add in the same ion that we have in the buffer system. Okay, that we have in the buffer system. So what will be the consequences, okay, the consequences of adding same ion that we have in the buffer system. Okay, same ion as what we have in the buffer system. Apakah consequences-nya? Okay, so obviously, okay, it will cause the equilibrium to be disturbed. Okay, dia akan mengganggu equilibrium lah. Imagine like you are increasing the concentration of one of the reactant or product. Okay, so that is what we call common ion effect. Okay, so the common ion effect is the shift effect. The effect is the shift in an ionic equilibrium caused by the addition of a solute that takes part in the equilibrium. Okay, all right. The presence of a common ion suppresses or stops the ionization of a weak acid or a weak base. Okay, so the presence of a common ion suppresses or stops the ionization of a weak acid or a weak base. So they suppress ataupun they stop the dissociation of weak acid ataupun weak base. Okay. Right, so let's look at an example. Consider mixture of this salt, okay, and this weak acid. So this is buffer system lah. Kita ada salt, okay, and the weak acid. Okay. The reason it is called common ion because dia ion yang sama. Okay, you are putting in ataupun place in the same ion as what we have in the buffer system. Okay, into the buffer system. Okay, so macam ni. Ini adalah common ion. So you add in CH3COONA. So you know that this will dissociate into sodium plus and CH3COO minus. When you add in this garam into weak acid, so what actually happened is that this concentration, because weak acid also produce this ion. Okay. Alright, so you ingat, okay, buffer kita ada weak acid and kita ada garamnya ataupun dia punya conjugate base dia. Okay, ataupun dia punya conjugate lah, dia punya weak ataupun conjugate dan its conjugate, right? Okay. So what we do is we actually in order to produce buffer, okay, kita masukkan garam ni because we want to supply this ion. Kita nak supply this ion. Okay, because kenapa? Kalau kita nak harapkan the weak acid ni, the weak ni to produce this ion, it will be very, it's not enough lah. It's not enough because you know the dissociation of acid is very, very low. Okay, dia partially dissociate. So mengharapkan acid to produce this ion is not, not apa nama tu? It's not sufficient. It's just not enough. Okay, so that's why we add in this salt because this salt produce this common ion. See, common ion. The reason it is called common ion because it's the same. Okay, sekejap ya guys. Hello. Salam. Oh, kelakar. Tak pernah. Macam mana lah kena tukar. Kena, habis kalau letak tak guna kan? Yeah. Habis macam mana tu nak cancel ke apa? Oh nanti saya edit balik. Itulah saya ingat kalau dia tak digunakan, jadi kok ada efek ke apa kan? Tak ada efek ke? Okay, okay. Okay, sorry for the interruption just now. Kat mana tadi? Okay, common ion means dia ion yang sama. Okay, alright. So when you add in this salt, they produce this ion, which is the same ion that we have for from the dissociation of the weak acid. Dia sama. So tu nama dia common ion. So apakah efek dia kat sini? Okay. So just now tu dipanggil common ion. Okay, so example, so acetic acid in water dissociate slightly to produce some acetate ion. So tu kita tahu dia acetic acid memang partially dissociated. Dia partially dissociate in water, right? So it produce low concentration of the acetate ion. So that's why we have to add in garam to support the buffer system. However, so ni, if sodium acetate is added, it provide a source of this acetate ion. Yes, it is true. And the equilibrium somehow shift to the left. Okay, so it will shift to the left. Why? Kenapa? Because bila ini, dia macam Chatelier last time lah. So this concentration, when you add in, so when you add in the salt, so it produce the same ion, it dissociates and produce the same ion as the weak acid. And therefore, this concentration will increase. So, bila this concentration increase, it will shift to the left. Kan? Nak reduce balik stress tu sebab concentration dah increase. So, it need to shift to the left. Okay. So, that is what we call the common ion effect. Okay. So, bila dia shift to the left, guys. Ke kiri. So the addition of this acetate ion, which is the common ion, okay, sebab dia ada dalam salt and also weak acid, it reduces, okay, dia reduces ataupun dia suppresses the percentage dissociation of the acid. Okay, they reduce ataupun suppress, okay, the dissociation of the acid. As you can see, they shift to the left. They shift to the left. Kalau ke kanan, dia dissociate. Faham? Acid dissociate to produce this product, these two product. Tapi since dia pergi kiri, dia tak dissociate. Okay, bukan tak dissociate, I mean dia suppress. Suppress means mengurangkan lah. Okay, ataupun reduces the dissociation of the acid because it is moving to the left, not to the right. Kalau dia to the right, dia apa nama word dia tu, dia menggalakkan the dissociation of the acid, but this one they turn to the left, they shift to the left. Okay, so that is what it meant by reduces ataupun suppresses the percentage dissociation of the acid. Okay, ni common ion effect. Yang tadi yang awal-awal tu kalau OH minus masuk, H3O plus masuk dalam buffer system. So what happened? So the acid dengan conjugate base and conjugate acid will counter attack the added H2O plus dengan OH minus. Yang this one pula, yang common ion effect ni adalah bila kita masukkan, bila kita add in add in the same ion in the system. Okay, in order to jadi buffer tu, so kita akan letakkan the common ion. Okay, so dia produce buffer, but at the same time it suppresses the percentage of the acid dissociate. Okay, faham ke? Masuk okay, do you have questions so far related to common ion effect? Are you guys following so far?
Yes, madam. Okay.
Yes, madam. Okay.
Okay, alright, good. Okay, moving on. Kita nak masuk calculation, okay? Alright, so make sure yang part understanding concept tu you betul-betul strong lah. Okay, so now we are going to, we cannot run away from the calculation of pH, okay? But for this time around, you have to calculate the pH of a buffer solution, okay? So there are two methods used to determine the pH of a buffer solution. One is by using the traditional way, which is the conventional ataupun yang paling, I mean dia punya original way, okay, to find pH, which is using ice table. Okay, alright. So ice table ni memang dia yang traditional lah. Maksudnya you don't have to memorize any formula or whatnot. So just use ice table and then find out the X and whatnot terus. Okay, but but the thing about ice table is that dia punya steps tu can be lengthy lah. Okay, so the steps requires the step required are considered as a lot lah, banyak step dekat situ. Okay, tapi alternative to that we have a formula. This is specifically for buffer that is known as Henderson-Hasselbalch approach ataupun method. Okay, so we are going to be using this formula ataupun this equation, Henderson-Hasselbalch equation. Okay, kenapa? Again, this equation allow us to quickly calculate the pH. Okay, so this is opposite to using ice table. Ice table, like I said just now, it has a lot of step that you have to go through. Okay, so kalau kita pakai formula tu, normally kita assume, kita pakai assumption kan. But if you are using ice table, the conventional ice table, maksudnya kita tak assume ke apa-apa, kita proceed as is. Okay, maksudnya kita tak abaikan the X value and whatnot. Kita proceed apa nama tu for calculation of X. Okay, and then throughout kita calculate the pH. Tapi banyak step lah. But this one is we are able to determine the pH of the buffer solution, okay, faster, okay, quickly from the initial concentration of the buffer component as long as the X is small, approximation is valid. See? Nampak tak? So kalau ada pakai formula ni, normally kita akan ignore the X. Katakanlah 0.5 minus X, kita ignore the value of, kita assume that the X is negligible. Okay, it's negligible. So baru kita boleh pakai this Henderson-Hasselbalch. So kalau X ni is not negligible, that means we cannot supposedly it's not suitable to use this equation lah, sebab dia error lah dekat situ. Okay, right. Tapi untuk kita punya syllabus memang kita akan pakai Henderson-Hasselbalch equation ni. Okay, so not to worry about that. Okay, azan. Okay, kita stop sekejap. Okay, right, so let's continue. Okay, so Henderson-Hasselbalch equation. So use this as our reference. So this is the general equation of weak acid. Okay, kita bagi contoh lah. Tapi it is also applicable to weak base. Okay, maksudnya kalau dia tunjuk weak acid macam ni, it's the same thing for weak base. It's just that this one you be using Kb lah. Okay, and this one should be OH minus. Okay, and this one too should be the weak base. This should be the conjugate acid. Okay, all right. So normally, okay. So how did the equation, okay, derive? Maksudnya macam mana this equation kita dapat? Okay, so macam mana dia came about? So it's actually from the Ka expression. Okay, so this is the Ka expression, right? That normally we can get from the ice table, from the equation. Okay, all right. So we at the end of the day we want to find the pH. So we know that pH is equal to negative log concentration of H3O+, right? So kita keluarkan the H3O+, so become dia punya main lah. Okay, on this left side, and then kita rearrange everything, Ka times Ha over A minus concentration. Okay, alright. So this is just an arrangement saja. Nampak? From here to here. So kita jadikan H3O+ sebagai kepala sebab sebagai dia punya headline, because later we want to use this concentration of H2O+ to find the pH. Okay, and then from here to here, okay, what we do is we negative log on both sides. Okay, kita negative logkan on both side. Negative logkan on both side. So bila you negative log on both side, bukankah you dapat pH? Okay, alright. So ni logarithm logarithm maksudnya how do you to expand from negative log of this into this. Ini patut you lagi tahu matematik daripada saya. Okay, so you negative log, since this is darab, so dia akan jadi tambah, betul tak? And ni HAA minus sebenarnya kenapa dia terbalik? Because dia adalah operasi tolak sebenarnya kan. Lastly, okay, so bila kita rearrange everything so that kita dapat pKa plus, kita nak plus, kita tak nak tolak kat sini, so kita kena rearrange this one. Okay, atas dan bawah ni. So as you can see, nampak HA dia terbalik atas dan bawah. Okay, so pH is equal to pKa plus log A minus the conjugate base over the weak acid. Okay, the weak acid is at the bottom. And the conjugate base ataupun yang garam tu is at the top. Okay, so this is the formula of Henderson-Hasselbalch equation for buffer. That means you can calculate the pH right away. Just insert into the formula. Okay, same goes to, do we have POH? If we have, imagine if we have weak base lah. Okay, basic buffer. Okay, so you will be producing OH minus. For example, kalau weak base, you akan dapat Kb kan. So Kb you rearrange. Okay, you rearrange OH minus as dia punya this one. So Kb, okay. At the top here we have weak base over weak base over this should be plus lah. Dia punya tu? Base HB plus. Okay, ataupun saya boleh letak weak base ataupun ini salt dia. Okay, alright. So when you rearrange, macam biasa you negative log kan on both side. Okay, negative log on both side. You akan dapat POH dulu. Okay, so for base, you akan calculate for POH dulu. Because you transfer to this side is the OH, bukan H3O+. Okay, so POH is equal to PKB plus log salt ataupun the conjugate base over weak base. Okay, everything is the same as this one. It's just that you are calculating for POH. That means later on you kena 14 tolak POH to get the pH. Okay, pOH dia memang ada extra step because what we want is pH. Kita tak nak pOH. Tapi in order to get the pH, you have to calculate for the pOH first. Okay, alright. So this is the equation that you will be using, okay, for buffer. Just to highlight here, for the molarity, okay, we know that molarity, the formula of molarity is concentration equal to mole over volume in liter, right? So this is the formula of molarity. So when we expand the concentration of both conjugate and acid, okay, conjugate and acid, bila kita expand kan, kembangkan dia, kita akan dapat mole of the conjugate over the volume over, okay, mole of the weak acid over volume. Okay, but the thing about this one, the volume should be the same lah because they are in the same solution. Betul tak? They are in the same solution. So alternative to this, okay, alternative to this, you can also use mole. Boleh juga pakai mole. Okay, this is based on understanding that both conjugate base and the weak acid are in the same solution. Therefore, the volume should be the same. So dia bila you akan end up cancel out. Betul tak? Dia akan jadi begini kan. Nanti you naik ke atas this one, you akan dapat V dekat atas and HA dekat bawah kan. So V cancel dengan V dekat sini. Okay, that's why you end up with this formula. Okay. So this is alternative 1 or alternative 2. If you have concentration are given to you directly, you may use concentration. If you are not given the volume, you may use the mole. Okay, so this is based on understanding that both component are in the same solution. Okay, baru kita boleh abaikan the volume because at the end of the day it will be the same and it will be cancel out. Okay, so ingat dia punya formula right now. pKa plus log of conjugate base ataupun salt over the weak acid. Okay, kalau weak base, kalau basic buffer, that means you will have pOH is equal to pKb. Okay, pKb plus log concentration of weak base over, log concentration of salt ataupun conjugate acid over concentration of weak base. Okay. Okay. So normally the pH, the equation, okay, is generally expressed as pH pKa plus log base dekat atas, acid dekat bawah. Okay, base dekat atas, acid dekat bawah. So in acidic buffer, okay, you may use it's the same lah as just now, conjugate base dekat atas, acid dekat bawah. Maksudnya dia punya apa nama tu, cara dia like I said just now kan, yang ni formula dia pKa and then you have pOH. Saya tulis pKb plus log of conjugate acid over weak base. Okay, and then later you nak cari pH, 14 minus pOH. Okay, tapi you akan cari pOH dululah. Okay, you have to find the pOH first. Okay, alternative to this, okay, alternative to this, conjugate acid sama je kan. Okay, alright, so this is the one that I've mentioned to you just now. Ni, for basic buffer. Okay, pH is equal to 14 minus pOH. Okay, ada lagi satu method yang di mana dipakai dia basic buffer but you can straight away calculate the pH. Okay, you can straight away calculate the pH. Okay, pH, pK, this should be pKa. Okay, but this one dia kalau ikutkan yang tadi, yang contoh yang saya bagi tadi, conjugate acid dekat atas, base dekat bawah kan. Tapi kalau you nak directly calculate the pH, you kena follow this one. Base species must be at the top, acid species mesti dekat bawah. Then you can calculate directly. You boleh terus dapat pH without having to go through this step. So ada dua option sekarang. Faham? Ada dua option. Satu, you akan go for POH, that means you have to use PKB. Tapi weak base, maksudnya the base should be at the bottom. Weak base lah, weak base dekat bawah, conjugate acid dekat atas. Sama juga acid buffer ni. Yang weak tu dekat bawah, yang garam dekat atas. The conjugate must be at the top. Tapi alternative to basic buffer. Sebab basic buffer ni you kena calculate POH dulu and then baru you tolak kan. Tapi alternative to this one, katalah nak cepat, okay, you may calculate the pH directly, but you have to be careful dekat sini. Di atas bawah dia akan bertukar. And then this one should be pKa lah. Okay, so kalau you ada Kb, you kena tukar kepada pKa. Okay, so base species maksudnya weak base akan dekat atas, base species. Acid species which is the conjugate acid dia dekat bawah, which is nampak tak berbeza dengan yang kalau kita kena calculate POH dulu. Okay, alright, so maybe I can put in here pH alternative this is step number 1. Alternative you kena this one should be pKa plus log weak base over conjugate acid. Okay, this is for basic buffer. Acidic buffer is not a problem because you can calculate the pH directly. Basic buffer, you either go for POH, PKB, okay, base dekat bawah, conjugate acid kat atas, and then you minus with 14. Alternatively, you can calculate the pH directly but using this formula. So nampak tak dia terbalik dekat situ. Okay, so it's up to you whether which one would which one do you prefer the best. You prefer untuk based on your preference lah. Tapi kalau personally, kalau saya, I would rather go for this first method. Sebab saya just hafal weak mesti dekat bawah, conjugate dekat atas. Alah, setakat pH 14 tolak POH tu, tolak aje kan. Tak ada masalah pun. Okay, so saya akan, I would go for option number 1 lah. Okay, sebab saya tak mau tukar-tukar. Nanti kan, pening. Mana satu lah yang kena tukar, yang kat atas dengan kat bawah tu. Dalam exam dia blank. Okay, but it's up to you. Okay, which one do you prefer the best? Okay, alright. So these are the formula. Okay, let's look at example, guys. Okay, jom tengok contoh. Calculation of pH of an acidic buffer solution. So how do we calculate the pH of the buffer? So this is an acidic buffer solution. Okay, so how do we know that this is an acidic buffer? Because the component used in this buffer is acetic acid and also sodium acetate. So this is the conjugate base. Okay, so in the buffer solution, these are the concentration of the salt ataupun the conjugate base and the concentration of weak acid. So dah given directly lah to you guys. Calculate the pH of this solution. Ka is given. Okay, Ka is given. So dia calculate the pH. That means okay, you tengok. So this is acidic solution kan. So the acidic solution means you tak payah pening kepala dengan POH ke what not. Okay, and then you need the Ka. Yes, the Ka is given to you. Okay, so this is buffer. That means you have to write. The easiest would be by using the Henderson-Hasselbalch lah. By using the Henderson-Hasselbalch. Okay, so in solution, as you can see from the solution, we have two methods. Jom kita try dua-dua. Okay, let's look at both methods. Okay, so if we are using ice table, okay, so you need to have equation and then this ice table. Okay, so initially, okay, we have CH3COH and nampak tak beza dia? Guys, nampak tak beza dia? Okay, kalau normally equation yang dulu yang ice table yang biasa, Initial kita hanya ada dekat sini, yang ni 0, yang ni 0. Betul tak? 0, 0. But this is buffer. Okay, buffer maksudnya like I said, dia ada at the beginning awal-awal pun dia dah ada this and this, okay, insignificant amount. So nampak tak apa yang you kena buat adalah you fill up dekat initial tu for the weak acid and also for the conjugate. Tu beza dia dengan weak acid punya dissociation last time. Kalau weak acid punya dissociation ataupun weak base punya dissociation, you akan letak sini 0, 0. Tapi ni buffer. Buffer dia ada acid dengan conjugate. So dia ada value dekat sini. Okay, so hope you guys notice that. Okay, so apa beza yang dulu punya ice table dengan yang buffer punya ice table? Ni, value ni ada. Last time tak ada. Last time 0. Okay, alright. So bila change buat macam biasa, negative x, positive x, positive x, equilibrium 0.09, the initial minus x, okay, the initial minus, plus x, x. Okay, so nanti at the end of the day, what we want is this concentration. Betul tak? Kita nak H2O plus punya concentration. Okay, so next we need to have the Ka. This is the Ka punya expression. So this is the Ka value given from the question. Okay, so ini punya Ka kita dapat daripada dia punya equation. Okay, we get from the equation of the buffer. Okay, equation of the weak acid here. Okay, and then cari x. Okay, kita cari x. As you can see, this these are all can be neglected. Kita abaikan lah. Okay, kita assume kita abaikan. Yang mana kita boleh abaikan tu kita abaikan lah. Okay. Tapi kalau conventional ice table, kalau tak sebenarnya tak abaikan. Like I said, this is simplifying assumption sebenarnya. Tapi guna Ka expression throughout the calculation. Kita tak pakai formula sebenarnya. Okay, so kita selesaikan, dapatlah X and then insert into pH, dapatlah ni. Nampak tak? Familiar tak step dia tu? Okay, the thing about ice table ni adalah dia pakai step yang sama je. Dia nak cari X and that X represent the H2O+. See? So you tak payah pening-pening nak pakai formula yang mana ke apa. Okay, so buffer ke apa ke, tak kisah. You pakai the Ka expression in order to calculate X. It's just that bila you buat the ice table, you kena alert dengan this concentration. Okay, initially dia dah ada value for this one. Last time we don't have value for this one. It is both H3O plus dengan the conjugate base are equal to 0. Tapi ini dah ada. And then from there, okay, you have the Ka expression and then you insert the value here. So ini depends kepada you punya value dekat dalam table. Kalau table you salah, definitely you punya Ka salah. So that is what happened for your test. Okay, bila table dia salah, so dia punya Ka expression dia tu, Ka expression dia boleh dapat betul, tapi dia punya, bila dia nak fill up the value dalam Ka expression, dia salah. Okay, so be careful dekat ice table ni. Sebab you punya Ka expression will rely on your ice table. Okay, so ni macam biasa cari X dan masukkan dalam pH. If we are using Henderson-Hasselbalch equation, okay, so you have the equation. You have the equation with you. Okay, and then you use the formula, the equation. So this is the equation. So atas, bawah should be weak acid, atas should be, okay, at the top we should have the conjugate base. Okay, and then you masukkan je lah. Sebab everything has been given to you kan. So insert, there you go. You dapat 5. So very quick lah. Okay, this method does not requires you to write the Ka expression. Tak perlu, just insert the value. You can straight away use calculator. Okay, tapi ice table tadi dia kena buat kan, kena buat Ka expression and then kena find out, oh kalau involve quadratic, that means you have to solve for the quadratic equation first and then you calculate for X and then masukkan dalam pH. Okay, panjang cerita dekat situ. Okay, so let's look at for basic buffer solution. Cuba try calculate for basic buffer solution. Calculate the pH of buffer solution consists of NH3. So the molarity is given, and H4Cl. So as you can see, it is related. So NH4 plus is the conjugate acid of NH3. Okay, so both concentration are given. So dia tak cakap pun dekat sini dia adalah basic buffer. Cuba tajuk kat atas ni lah. Okay, but you have to know. In case dalam exam, dia normally dia tak, kalau dia boleh cakap, tapi dia tak perlu pun cakap. You should identify whether this is basic buffer ataupun acidic buffer. So this is basic buffer. Okay, so because NH3 kan, NH3 is a weak base. And then the PKB is already given to you in the value of PKB is already given to you. So you don't have to, normally it would, the value is given in terms of KB. Tapi dah bagi PKB, tak payah susah-susah dah lagi. Okay, alright, so this is the equation. Okay guys, maybe you can replace this one with, kita tak biasa lah dengan ni. Kita biasa dengan, ayo, this is another option yang saya cakap last time. Ingat tak yang saya kata this is with respect to the reference equation. Okay, so as you can see dia berubah. So normally kita akan pakai yang weak tu sebagai kita punya reference equation. So kita pakai yang ni. Tapi tak salah pakai yang ni, cuma tak nak awak pening. Okay, yang macam ni kan. This one, kan normally kita pakai weak. Sebenarnya kita boleh the other way round. Kita boleh buat macam ni. H2O. Dia jadi CH3, COO, H plus OH minus. This is conjugate base kan? So dia boleh jadi ini sebagai reactant. Boleh. Dia the other way round. So you decide you nak reference you punya equation of reference tu yang mana. Tapi kita based on our slides here, kita gunakan yang weak tu sebagai kita punya equation of reference. Okay, sebab kalau you pakai yang ni, so dia punya direction will be opposite lah. Tu kalau ini ke kiri, ini akan ke kanan. Okay, so inilah yang berlaku dekat sini. Dia terbalik pula. Dia bagi terbalik pula. Okey, tak payah pening-pening. Okey, kita pakai, boleh pakai dua-dua. Okey, tak apa, saya tunjuk dulu. NH3, H2O, kita pakai weak base dekat sini. Okey, jadi NH4 plus OH minus. Sebab NH3 is a weak base kan. So kita pakai dia punya dissociation of the weak base. So this is the equation. Or alternative to this, mana H2O ni? Tak mau lah. Ganti guys, ganti yang lain. Alternative to this, we can also have NH4 plus H2O. Okay, becoming NH3 plus H3O plus. Sebab this is conjugate base, betul tak? It's conjugate base. This is the weak base. Sorry, this is weak base, this is conjugate acid. Sorry guys, madam dah berbelit-belit tadi. This is conjugate acid. Bila kata acid, that means you should produce H3O plus lah. Regardless dia conjugate ke tak conjugate. Kalau acid, it should produce H2O plus. If it is a base, it should produce OH minus. Okay, so you may use any of this equation, tapi you kena be careful. Okay, so you kena identify yang mana adalah conjugate base, yang mana adalah base, yang mana adalah acid, yang mana adalah conjugate acid. So that's why saya prefer stick pada satu. Okay, yang kita buat equation tu based on weak. Is either weak acid ataupun weak base. So focus on, kalau saya, I would prefer to this ones. But throughout the slides tadi, kita dah stick. Kita dah ditunjukkan dengan yang weak punya equation. NH3, kita ada NH4+. Okay, so this is weak base, this is conjugate acid. Okay. Alright, so cuba tengok. Okay, you may use this one, POH, masuk PKB, log of this one over. So bawah weak base, atas conjugate acid. Kan concentration semua dah bagi kat atas tu. Even this one is already given to you. Dan masuk sajalah. So you akan dapat POH dulu, and then pH minus pH is equal to 14 minus this POH, you got it 9.2. This is option number 1 lah, yang mana saya pun prefer this one supaya saya tak pening-pening nak tukar atas dan bawah. Alternative to this method, we can directly calculate the pH. Maksudnya without having to minus with 14. The POH with 14. Tak payah kita skip satu step yang tak sangatlah menyusahkan kat situ. Tapi tak apa, since we have it here, so let's just go through. Okay, so pH is equal to pKa log of, kat atas mesti base species, syarat dia. Bawah acid species. Tu je syarat dia. Kalau nak pakai pH straight away, atas mesti base species, bawah acid species. So ini mesti pKa, tak boleh pKb. Tapi still juga kan, you kena tolak juga kat situ. Okay, alright. Cuma you kena jaga-jaga So this would be terbalik, see? Dia terbalik. Okay, so you tolak and then insert, there you go. Your final answer. They should be the same. Dia kena sama. Kalau dia berbeza, itu maksudnya you salah kira. Okay. Right, question. Okay guys, try to complete this checkpoint. Try to do it on your own. Cuba saya bagi like 4 minutes for you to try out this checkpoint. Cuba try. Dah siap, move to the other checkpoint. Okay. Okay, cuba try. Ada question, please ask me. Okay, all right. So, are you done for question 1, guys?
Yes. Yeah.
Yes, madam.
Yes, madam.
Yes, madam.
Yes.
Right, good.
Madam.
Okay, so let's look at the answer. Okay, but before that, let's go through the question very quickly. Okay, a solution is prepared by mixing 500 ml of 0.1 molar sodium hypochlorite and 500 ml of 0.2 molar hypochlorite acid. Okay, so calculate the pH of this solution, and then the Ka of the acid is given, Ka of the weak acid. So you imagine, you ada dua beaker of separate solution. Okay, so this is 500 ml of 0.10 molar NaOCl, the conjugate base ataupun the salt lah. Okay, the source of the source of the conjugate base. And then this one kita ada 500 ml of 0.2 molar of HOCl. Okay, alright. So in order to produce buffer, to prepare buffer solution, these two need to be mixed with one another. Okay, so obviously the volume will change. Okay, so it's no longer 500 ml each, dia akan jadi berubah lah. Okay, dia punya total volume tu will be different. So dia akan bertambah lah, obviously. Okay, so dia akan ada NaOCl plus dengan HOCl. So this is acidic buffer. Okay, alright. So obviously you kena pakai ni lah. pH, pKa, this is the formula. Concentration. Is it? Ada log ke? Tak ada kan? Ada log ke? Ada log ke? Ada log. Atas bawah HOCl, the acid, bawah kena yang weak, atas adalah dia punya conjugate. So atas should be OCl minus. Okay, the concentration. Bila dia tunjuk sini, okay, kan kita ada dua option kan, you can go for the mole ataupun you can go for the concentration. Okay, so you should get the same answer. Okay, ada dua option dekat situ. So kalau you nak pakai concentration dekat sini, if you choose to use concentration, you are not supposed to use the concentration, the initial concentration before the mixing. Okay, before dia bercampur. Itu salah. You akan dapat jawapan yang salah. Sebab concentration yang dia maksudkan ni adalah concentration bila dia dah bercampur. Okay, bila dia dah bercampur. So you kena consider that. So jangan ambil concentration yang dia bagi siap-siap ni terus you masukkan dalam the formula and then calculate terus. You akan salah. Okay. Alright. So kalau you nak cari the new concentration, maksudnya yang dalam satu solution buffer tu yang dah di-combine. So you kena ni lah. Kena cari balik lah. Okay. You kena extract out the mole from this. Okay, nak kena extract out the mole. So you ada 500 ml kan? So 500 ml. Sekejap. 5, bukan. Mana nak remove this? Okay. Right. Eraser. So misi dia adalah you kena okay. Alright, so you ada 500. This is for 1 liter. The mole is 0.1. Betul tak? Kalau you extract out 0.1 molar is also equal to 0.1 mole per 1 liter, right? Okay, that means this is for 1 liter. So kalau in 1 liter of solution you have 0.10 mole of sodium hypochlorite. So what if you have 500 ml? Okay, alright, so 500 ml. You nak cari berapa mol kan? So down here should be 1000 ml. Up here should be 0.10 mol. Okay, alright, so you cancel out in order for you to get the mol of. This is for NaOCl. Okay, alright, so satu bahagian 1, 2, 3. So berapa? 0.1 dar 10 kuasa negatif 3 mol. Dah ada. Dah halang-halang kena cari mol kan? Why not kita just pakai mol je dekat atas ni? Okay, sebab alternatively you can also pKa plus log mole of OCl minus over mole of HOCl. Okay, alright. So same goes for this one. Mana nak ni? Mana nak buat? Okay, alright. Oh, bukan. Okay. So now kita nak calculate for HOCl. Yang mana yang senang? Okay, yang mana you prefer? Kadang-kadang you prefer yang susah, tak apa. Yang mana yang you comfortable with. You nak pakai mole ke, you nak pakai concentration ke, doesn't matter. Okay, as long as dia punya steps to correct, then go ahead. Okay, next we have 500 ml of 0.2 molar. So kita ada 500 ml. Okay, so 0.2 molar is also equal to 0.2 mole in 1 liter of solution. 1000 ml lah, sebab saya nak potong kan. Ml cancel dengan ml. Berapa ya dia punya ni? Ni senang-senang pun nak tekan calculator Bila nak guna otak ni? 0.1. Betul ke? Sama tak? 0.1 mole. Is it? Guys? Easy ke?
Betul, madam.
Okay.
Yes,
Alright,
madam.
so pKa. So you pKa kan, the negative log 3.2 times 10 to the power of negative 8. So tambah log. Okay, up here should be, sempit lah. Transfer kat bawah ni So pH is equal to negative log 3.2 times 10 to the power of negative 8 plus log mol tadi kita dah kira kan 0.1 darab 10 kuasa negatif 3 over 0.1. Ni. Tekanlah kalkulator. Dapat tak jawapan dia sama 7.2? Okay. So patutnya dapatlah if we are using mole. Kalau you nak pakai concentration, boleh, tak ada masalah. Okay, you cari, you dah jumpa mole kan? Ni dah ada mole. So you nak cari concentration. So bila you nak cari concentration, let me change the ink first. Okay, so bila nak cari concentration, new concentration lah. Okay, new concentration of NaOCl. So you ambil the mole, you divide with the volume. So the volume is 500 times 10 to the power of negative 3 in liter. Alright, so you dah dapat lah. You dapat concentration in molar. So this is, sorry, bukan 500 guys. 1000, 500 plus 500. See? 500 plus 500. Okay, total dia punya volume tu. So it will be 1000 guys. Okay, careful This one you should be careful. Okay, the new one, the buffer. So it should be divided by 1000.
Medium.
Okay.
Medium. Yang NaOCl punya mol tu 0.05.
Ya ke? Saya ya, logiknya ni 5 darab 0.1. Ish, 500 kan? Lagi. Adalah macam pelik. Kecil sangat tu value tu. Okay, salah. Jangan jadi macam medium, salah tekan kalkulator. Okay, 0.05 mol. Macam serabut lah kalau salah ni kan. Macam pakai bahasa macam nak padam ni semua. Apa tadi? 0.05 mol. This is for NaOCl. So you proceed for HOCl. You dah dapat mol ni kan? Divided by 1000 juga. Okay, and then insert into this. Still you akan dapat apa nama tu, value yang sama. Okay, ada dua option lah dekat situ ya. Alright, so this is the one. 1000 is equal to 1 liter. Okay, so tadi make sure in liter okay, make sure sebab you concentration need to be in molarity, in molar. Okay, alright, so another alternative just now is by using mole. Okay, itu pun sama, lebih kurang sama. It's just that now you are given the base. You diberi base. Okay, you diberi 0. Let me just check. Apa ni bos? Nampak macam unfamiliar dengan dia punya ni. Alright. Okay, so this is the base. This is the weak base. Kita consider dia sebagai weak base. Sebab apa? Satu, dia bagi PKB. PKB of this one is NH4OH. Okay, alright. So this one kita tahu dia produce NH4+. Betul tak? So this would be the conjugate acid lah. Okay, so once you have identified, yang paling penting when you are using Henderson-Hasselbalch, you kena tahu siapa base, siapa acid. Okay, siapa base, siapa acid. Sebab you nak place in dia dekat dalam yang mana kat atas, mana kat bawah. Alright, okay, so same goes to this question. You can use concentration and you can also use mole. Okay. Sama je soalan dia. So PKB is already given to you in this value, dah siap-siap negative log kan. So insert into PKB. If you choose to use pH directly, tapi kena be careful lah. This one you kena cari pKa. Okay, kalau tak atas kena apa? Base species, right? Bawah kena acid species. Kalau you nak pakai pH, ini kena be careful. So you kena cari pKa. Alternatively, you kena pakai POH lah. So you akan PKB plus log. Formula kena hafal So imagine formula log ni tertinggal. Common mistakes. Dalam test banyak yang buat macam tu Tertinggal ni lah, tertinggal tu lah. So atas would be conjugate. acid ataupun the acid species, bawah will be the base, weak base. Okay, you boleh pakai mole or you can also stick to concentration. This is the answer. Okay guys? Betul ke jawapan dia kan? Ya betul, 8.6. Okay, alright. So this is by using concentration. If you are, if you just, if you decide to use mole, okay, then you, the answer should be the same lah, 8.6. Tapi nak try. Okay, boleh nak practice guna mole pun boleh juga. Okay, cuma kat sini you akan lain lah. You tak adalah nak kena divide in 1 liter Okay, cuma please guys alert that you have to consider the total volume, betul tak? Kenapa? Ni dia betul. Salah ni. Mana ada 1 liter ni tersalah ni. Okay, solution ni pun salah Kan 1 liter 200 plus 100 it will be 300. So convert into liter it will be 0.3 liter. Ni terlupa dia typo kot. Okay, so it should be 0.3 liter divided by 0.3 liter. The total of volume for both solution. Okay, right, done. Right, we are running out of time. Saya plan nak masuk topik 4 ni. Okay, any questions so far guys related to calculation of pH for buffer solution? Anything guys that you would like to highlight? Please let me know. Ada ke isu? Faham ke apa ke? Anything?
Tak ada.
Tak ada Okay, alright. Tak ada Tak ada. Ya betul. 4 kelas, 4 group tak ada ya. Semua clear ya. Alright. Okay, if tak ada, let's proceed. Okay. pH of a buffer solution. Okay. What is this? Buffer solution can also be prepared by using Henderson-Hasselbalch equation. Okay. So first, let's say lah, you decide to prepare a buffer. You can prepare a buffer solution. So first, what you need to do is, okay, you may use the Henderson-Hasselbalch as your reference. Okay, so based on the Henderson equation, kalau you nak prepare buffer, katakanlah you nak prepare buffer. Okay, you nak prepare buffer. You kena tahulah pH berapa you nak prepare buffer ni. Okay, bila you dah tahu, okay, aku nak prepare buffer 8, around 8 macam tu lah. Next adalah apakah spesies acid dengan base yang you nak guna. Sebab as you know, we have a lot of weak acid and weak base. Betul tak? You nak acidic buffer, you nak basic buffer. Okay, that's why you have to decide for your desired pH. And then you punya pairing. You punya conjugate base dengan acid dia tu kan. Kata nak go for acidic buffer. So you nak kena weak acid tu, kan ada banyak acid. Nak pilih yang mana? You kena decide. Okay, and then once you have decided the acid that you want to use, that you decide to use, you kena decide on the concentration. Betul tak? That's why you can use the Henderson as your reference. But you from the equation, you are the reference guys tu. What need to be you kena ada beforehand before you could prepare your buffer solution. Kena ada pH, betul tak? And then kena ada concentration of the acid or and the salt. Okay, those kind of thing. Okay. C, you have to choose a conjugate acid-base pair. Okay, so the pKa of the weak acid component should be close to the desired pH. So dia punya tips dia adalah, you dah decide you punya pH kan? So you akan go for acid yang dia punya pKa is the closest dengan your desired pH. Okay, so you boleh narrow down sebab tak semua weak acid will have pKa closest to your desired pH. So you boleh narrow down lah, oh yang ni je yang aku boleh pilih in order to prepare my buffer solution. Okay, so you will be based on your pKa if you decide for acid lah. Okay, kalau you nak decide for basic buffer, that means you go for pKb. Okay, alright. Okay, and then you have to calculate the ratio of buffer component concentration. Like I said, so you need to be based on this. Okay, sebab you nak kena tahu the concentration of these two. Okay, so you kena check on the ratio of these two lah. Okay, alright. Example, suggest one of the following acids should be used to prepare buffer with a pH of 4.5. So macam mana nak tahu ni? Okay, tadi kan dah beritahu tips dia, cara kalau nak prepare buffer. Okay, you kena based on the pKa. Okay, so this is a buffer that you would like to prepare, 4.5. Macam mana kita nak select ni? Ni dalam banyak-banyak yang dibagi ni, how do we select which one is the best acid to be used as our buffer component? So we have to calculate for the pKa. Okay, after all your pH is 4.5, so you calculate the pKa lah and then compare which one is the closest. You compare, so check ni pKa dia berapa, ni pKa dia berapa, calculate. Cuba calculate sekarang. Cuba calculate, tekan calculator kat tepi tu. pKa dia berapa, pKa berapa, and then compare, and then turns out that acetic acid is the closest, has the pKa closest to 4.5. Cuma dia tak beritahu lah kat sini so you kena calculate sendiri. Berapa yang closest to. What do you mean by closest? How close is close? Okay, alright. Example 4, an environmental chemist needs a carbonate buffer of pH 10, okay, to study the effect of the acid rain on limestone-rich soil. Determine the mass of sodium carbonate in grams, ataupun the carbonate lah, okay, the conjugate base, must he add to 1.5 liter of freshly prepared 0.2 molar sodium hydrogen carbonate, okay, the acid species, to make the buffer. Okay, so jangan ingat soalan akan tanya pH je, not necessarily, as you can see. So this is the formula. The question can ask you to find the conjugate base. If the acid, the concentration ke, the mole ke, the Ka ke. Okay, pH tu memang common lah. You may use this equation. But you can also be asked in terms of mass of the conjugate base ataupun mass of the salt. Okay, concentration of the acid, boleh. Ataupun the ratio of these two, boleh. Okay, alright. So this is an example, okay, that shows other than pH, you can also be asked to calculate the mass. Nampak tak? Dia dah bagi pH, so you kena calculate the mass of sodium carbonate. Okay, so dia kata berapakah mass of sodium carbonate? This is the conjugate base, the salt lah. Okay, must she add to 1.5 liter of freshly prepared 0.2 molar sodium hydrogen carbonate. Okay, tak ada masalah. Ni sama je, kita play around dengan dia punya equation of Henderson just now. So have the formula first so that you can see apa yang sebenarnya you nak cari. You sebenarnya nak cari sodium carbonate kan? This one yang dekat atas ni. Make sure betul dia punya position you nak cari ni. But before you could calculate the mass, you kena determine the concentration first. Okay, you kena determine the concentration first, and then from the concentration, then only you can calculate the mole, then only you can calculate the mass. That's the plan. Okay, Ka is not a problem. This is also not a problem. HCO3 minus. Okay, not a problem sebab dia dah bagi. 1.5 liter. And then this is in solid. Maksudnya dia, let's just assume it will not affect the volume of the total solution. So the total solution will be 1.5 liter. Okay, so yeah, ini lah plannya. So ini pun dah ada. Tinggal nak cari concentration. From concentration you can extract out the the mole, and then you can extract out the mass. Okay, alright, pH pun dah given, this is 10. Dia make sure dia pH ke pOH. Ni dia bagi pH, so boleh lah. Okay, so there you go. Okay, you boleh pakai mole, sama, you boleh pakai mole, or you can also use concentration. Okay, okay. Mass, ingat dia nak mass. Ini you baru cari mole, and then this is the final mass. Okay, so since kita dah running out of time, so you try to complete this checkpoint at home. Okay, I need to finish few more slides for this chapter. Okay, so try buatlah. Okay, kita ada checkpoint 18. Yep, only this one. One more question, and then let's proceed to effective. Banyak lagi, banyak pula slide ni. Okay, right. Effectiveness of a buffer, guys. Okay, last but not least would be the effectiveness of a buffer. Okay, so as you can see, as we know, as what we have learned, buffer has the ability to resist the change in pH. Drastic change in pH. Dia ada kebolehan tu. Sebab apa? Dia boleh counter acid yang masuk, dia boleh counter base yang masuk. Tapi berapa lama? Okay, itu stress tu. Bila acid masuk, dia stress. Sebab dia kena counter the acid added. Okay, kalau tak, the system will be at stress and then the pH will go up, increase drastically ataupun go down drastically. So that's basically how buffer works lah. Okay, alright. So we have an effectiveness of buffer. So effectiveness of a buffer is to determine the efficiency of a buffer. Efficiency maksudnya kebolehan buffer tu dia nak bertahan. Dia nak bertahan. Macam kita lah, kita stress pun, kita ada level-level stress kita. Bila yang kita dah tak tertampung dah stress kita tu. Tu effectiveness awak. Maksudnya, alamak, ada satu test dalam masa satu hari, boleh lagi. Ada 2 test, boleh lagi. 3 test, dah tak boleh tahan. 3 test dalam satu hari. So, itu maksudnya you punya buffering region, you dah exceed the buffer capacity. You punya capacity nak tahan stress tu dah melebihi yang sepatutnya. Itulah maksudnya effectiveness. Okay, alright. So buffer solution work most efficiently when the ratio of the conjugate and the acid is close to 1. Okay, alright. So we are still going to be using the equation of Henderson. Okay, so macam mana kita nak tahu dia ni boleh tahan berapa banyak? Dia akan based on this ratio. Okay, so remember this is the this is apa tadi? Acidic buffer kan. So this is weak acid, this is conjugate base. So conjugate base dia punya purpose is to counter acid yang masuk. Weak acid pula to counter the added base. Okay, alright. So it would be efficient if these two dia punya ratio is equal to 1 ataupun closest to 1. That would be the best. Okay, maksudnya dia boleh counter amount of acid ataupun base yang masuk sama banyak. Okay, that's why maksudnya is equal to 1, more or less equal to 1 lah. So when apa? Kenapa tadi buat? Henderson guys, refer to Henderson. pKa plus log apa tadi? Conjugate base over weak acid, right? Okay, so this is the ratio yang kita akan play around lah. So it would be best if we could maintain this ratio is equal to 1. Maksudnya kalau concentration atas ni 0.5, kat bawah ni pun around that 0.5. Then only you akan dapat ratio dia equal to 1. Betul tak? Bila you dapat log is equal to 1, log is equal to 1 is equal to 0. Betul tak? Bila log 1, kalau you dapat ratio atas dan bawah, tak kisahlah asalkan dia atas dengan bawah punya concentration dia sama. So you akan dapat ratio is equal to 1. So log 1 is equal to 0. Boleh juga 0.8 over 0.8. Doesn't matter. Dia asalkan dia punya concentration atas dan bawah lebih kurang sama. Okay, so log 1 is equal to 0. And at the end, you akan dapat pH is equal to pKa. This is for buffer. pH is equal to pKa is for buffer. Okay, remember yang hari tu yang saya kata KIV last time, yang ditunjuk pH is equal to pKa dekat titration curve. You may refer to the titration curve last time. Okay, dia tunjuk dekat buffer region. Yeah, pH equal to pKa is for buffer. Okay, so kita akan dapat pH is equal to pKa when the concentration of the acid is almost equal to the concentration of the conjugate base. Okay, a buffer is most effective ataupun most resistant to pH changes when the concentration of acid and conjugate base are high. Okay, so kalau concentration of these two tinggi, maksudnya lagi banyaklah acid yang base masuk tu, dia boleh counter. Cuba you imagine you ada buffer 1 dan buffer 2. Okay, dia punya concentration of weak acid dia 0.5 dengan 0.5. Weak acid dia atas ni, bawah ni weak acid kan, atas ni conjugate base. 0.5 je. Still ratio dia 1, betul tak? Tapi kalau buffer 2 ni dia 1.5. Again, this is conjugate base, this is weak acid. Sama juga ratio dia 1. Tapi which one is better, guys? Buffer 1 ke buffer 2? Which one is better?
Buffer 2.
Yes. Buffer 2 is better. That's why dia semua balik kepada you punya konsep. You faham tak konsep buffer ni? Apa fungsi buffer? Okay. So conjugate base untuk nak counter acid. Weak acid nak counter base yang masuk. So kalau dia punya concentration higher, that means it can counter more acid and it can also counter more base. Okay, that's why dia kata when the concentration of acid and conjugate base are high and try to maintain the ratio is equal to 1. It is most effective lah. Most effective. Okay, kalau you ada 0.3 ataupun 0.1 dengan 0.1, so ratio dia 1 tapi dia boleh counter sikit lah. Okay, lebih je daripada 0.1 yang dia boleh cover, maaf, dia dah tak boleh cover sebab dah habis. Dah habis. So bila the moment dah fully consumed tu, kita place in atau kita add in more H2O plus or OH minus, the pH will goes up and the pH will go down drastically. Okay, sebab tak ada siapa dah boleh counter sebab dah habis digunakan to neutralize the acid and base. And then yet kita still masukkan lagi acid, masukkan lagi base. Okay, right. pKa of the weak acid mostly determines where on the pH scale a buffer can work best. Okay, so we use pKa lah to determine where on the pH scale a buffer can work best. So kita based on pKa lah. Okay, as long as the ratio of these two in a buffer solution is from 1/10 to 10/1, the buffer will maintain pH effectively. Okay, alright. So kita sebenarnya ada range. Sometimes it is not possible to prepare 1-to-1. Maksudnya atas dengan bawah ni kadang-kadang tak perlu pun dia kena exactly the same. Kadang dia subject to what we want lah. Okay, kalau kita dah tahu kita nak letak base banyak dekat dalam reaction kita tu, okay, and then kita kena lebihkan conjugate acid kita lah. Okay, dia subject to what we need lah. Okay, so kita still can prepare the buffer within this range. 1/10 to 10/1. Apa maksud ni? 1/10 kan 1/10, 0.1, 10/1 is equal to 1. Betul tak? 1/10 to 10.1. Okay, this is like plus minus guys tu. So kita boleh kata that the buffer still can behave effectively. So plus minus pH is equal to pKa plus minus 1. Kadang-kadang kita tak dapat pH is equal to pKa ni. So kita boleh cari option kita. Okay, kita boleh katakanlah kan kita nak pH kita is equal to 10.8. So kita nak cari acid yang pKa dia the closest to our 10.8 kan. So tak jumpa ataupun kita tak ada dekat lab. Okay, we don't have this acid in the lab. So option kita adalah kita pakai plus minus ni. Maksudnya kita punya range. Okay, so 10.8 plus minus 1. So tambah 1 dia akan jadi 11.8. 10.8 tolak 1. Apa ni? Bulat. Orang cepat ni dibuat hal pula. Tolak 1 juga tu 9.8. So you punya range for pKau adalah 11.8. 9.8. Sekejap ya. So you punya range will be 9.8 until 11.8. So banyaklah option yang you boleh cari for your pKa, for your acid. Okay, you can go as long as they're within this range. That means your buffer solution prepared later on is still effective. Faham? Okay, ini dia punya range dia lah. pKa plus minus 1. Okay. Banyak lagi ke? Okay. Right, so this is the effectiveness of a buffer. Okay. And buffer capacity. Saya ada mention juga kan the term capacity just now kan. Capacity is like capacity kita nak tanggung capacity of the buffer to counter the acid ataupun base added. For example lah, kelas kita ada day 1. Okay, kita ada day 1 lecture hall, and then that lecture hall can only accommodate, like for example, 60 student at once. Okay, at one time dia boleh support 60 student. So that is the capacity. Kalau you exceed that capacity, dia dah tak conducive. The hall will no longer be conducive sebab you akan ramai orang, banyak bercakap, you dah susah nak control the hall and whatnot. So everything pun ada dia punya capacity. Betul tak? So even the buffer also has its own capacity. Keboleh tanggungan. Okay, keboleh tanggungan. So that is what we call capacity lah. Okay, buffer capacity is the amount of acid or base that the buffer can react with before showing significant pH change. Keboleh tanggungan dia sebelum dia collapse, sebelum dia dah tak boleh tahan, sebelum dia burst. Okay, so it depends on the amount of conjugate acid or base in the solution. Okay, alright, so increases with increasing absolute concentration of the buffer component. So it depends on the increases. So the buffer capacity increases, okay, with increasing absolute concentration of the buffer components. Like I said here, macam ni yang tadi 0.5, this one, ni capacity dia. Kalau you ada 0.5 dengan 1.5, mana capacity yang lebih besar? Of course lah 1.5. Okay, because it can sustain more lah. Dia boleh bertahan lebih lama. Okay, alright. Initially in a buffer solution there is 0.1 mole of this conjugate base. If 0.1 mole of HCl is added, this will react completely with the 0.1 mole of the conjugate base to give 0.1 mole of CH3 COOH. Contohnya macam ni. Buffer U ada conjugate base, okay, ada this conjugate base dalam buffer U, and then you kacau buffer U tu, maksudnya you disturb buffer U tu when you add in HCl, you add in H3O plus lah. Okay, so this H3O plus, when it is added into your buffer system, your conjugate base of the buffer will neutralize this H3O plus. So, berapa banyak HCl yang dimasukkan? 0.1. So, berapa banyak conjugate base yang tentera conjugate base yang perlu dihantar untuk neutralizekan this HCl? The same amount. Ni 0.1 of conjugate base will neutralize all the 0.1 mole of HCl. So kata lainnya, so dia akan produce this one lah, CH3COH. Okay, so dia macam ni, dia punya equation dia. Okay, dia akan neutralizekan the acid H3O+. Betul tak? HCl, this supply H3O+. Producing CH3, COO, H2O. Okay, so nampaknya in buffer solution ada 0.1 tapi HCl yang dimasukkan 0.1. So habis pakai dah. Gone. All gone. Finish. Semuanya habis. 0.1 ni dah totally habis pakai untuk nak neutralizekan all the 0.1 H3O+. So agak-agak lepas tu nak masukkan lagi, buffer tu boleh tahan tak? Tak boleh, dah habis lah. Okay, there's no conjugate base available in the buffer because all has been exhausted. See, addition of 0.1 mole HCl exhausts the capacity of the buffer. Habis. Next, kalau you add in lagi HCl, the pH will definitely goes down drastically. Sebab dah tak ada base nak neutralize the acid added. Okay, sebab dia dah pakai all the capacity of the base. Okay, alright. So qualitatively, buffer resist significant change in pH if, okay, kita kena make sure lah added base tu kena less daripada acid yang ada dalam buffer. Barulah buffer tu masih boleh bertahan. Sama juga nak masukkan acid tu, kita kena make sure that it should be less than the conjugate base present in the buffer. Kalau lebih, dia dah melebihi capacity, so dia tak boleh dah resist the changes in pH. Dia akan shoot naik ataupun dia akan shoot turun. Okay, so dia akan based on this. Kita kena check whether dia lebih daripada mole of the weak acid dan mole of the weak base. Okay, this is very interesting kalau you faham konsep daripada awal. Kalau you tak faham konsep, you akan pening. Okay, and then after all, dia sama je macam kita punya style. Kita boleh dapatkan the logic. Kita tak susah sangat nak faham. Tapi kalau you faham lah, kalau you tak faham, cuba lagi. Okay, alright. We have question also for this one. Sekarang aku buat apa? Oh my god. Okay, we are totally kita dah running out of time. Tapi kita adalah sikit plan saya nak masuk topik 4. Okay, but next week ke? Yeah, next week. You punya quiz tu. Okay. Cuba check quiz 2 quiz 2 kena buat next week, so next week lah. Next week quiz 2 will cover redox reaction and galvanic cell. Tak apa, ni kita boleh buat hari Isnin kan. These two can be covered on Monday, so tak apa. Quiz 2 memang tak boleh buat apa-apa memang it should be next week. In terms of coverage boleh. So dia akan masuk redox reaction and galvanic cell and also buffer solution. Tiba-tiba dah bagi jawapan Tak apalah, we have few more minutes. Okay, tak perlulah masuk topik 4 tu, maybe we can settle for buffer. Okay. Okay, cuba buat ni. Cuba buat checkpoint 19. Let's finish off all the checkpoint then kita boleh tutup buku for buffer. Okay, what's the question? Buffer solution consists of carbonate and hydrogen carbonate conjugate acid base pair. So this is basic buffer. Is it? No. CO3, CO3 2 minus carbonate. Acidic buffer. This is acidic buffer. This is acidic buffer. Okay. Choose the following buffer that can neutralize the greatest amount of added chloric acid. Okay, you kena identify dulu. Ini base ke atau conjugate acid ke? Yang mana satu base, mana satu acid? You kena identify that one first. Okay, alright. So this is acid species. Kalau tak tahu dia weak ke apa, you letak acid species. This is base species. How do you know? Okay, CO3 2 minus plus H2O. Okay, it become HCO3 minus plus OH minus. So this is base species. Okay guys. Okay, bukan main teka-teka. Teka base ke acid kan? You buat equation. Okay, same goes to HCO3 minus plus water kan? So it will produce dia ada kena mengena this one dengan this one. So it produce CO3 2 minus. Kita predict the acid just now, right? Plus H3O plus. Since kita dah tahu this is the base, therefore this one definitely should be an acid lah. Sebab dia buffer kan? Kalau dua-dua base tak boleh juga. Tak boleh. Dia kena one should be acid, the other one should be base. Okay? Alright. So this is apa nama tu, kita ada acid dengan base. Okay, so dia tanya choose the following buffers that can neutralize the greatest amount of added HCl. Maksudnya added HCl dia akan supply the H3O+. Siapa yang kena counter H3O+? Base lah. So in this case base siapa? This one, CO3 2 minus is the base. Okay, alright, so is the base. So kita akan pilih yang mana? Jawapan dia tadi C Okay, alright, so kita prefer to go for same concentration because why? Kita nak dapatkan the ratio is equal to ataupun closest to 1. Okay, alright, so the answer is C, bukan A, bukan B, and bukan D. Okay, A dengan B ni dah reject awal-awal. Maybe C dengan D. Okay, the reason we choose C because the capacity is larger compared to D. The capacity for D is only 0.1. Maksudnya dia hanya boleh counter acid yang masuk sebanyak 0.1 molar saja. If exceeding this 0.1, definitely the pH will decrease drastically. Sebab HCl kan, acid kan, it will decrease. Okay, so that's why the answer is C. Okay? Okay ke? Faham ke? Are you guys there? Macam gelap bilik saya ni.
Faham, madam.
Okay, faham Alright. On to the next question. Okay, cuba buat checkpoint 20 ni. Pyridine act as a weak base with a Kb of given in a preparation of its buffer solution 0.15 mole of the conjugate acid, the salt. This is the salt. This is the weak base. Dah carbo dah dekat situ, dah carbo is added into 1.5 liter of 0.125 molar pyridine solution. That means okay, this one will be added into pyridine solution. So this is the volume of pyridine solution. Maksudnya kita boleh assume that the volume will still remain the same. Sebab dia tak bagi any info on this one. Okay, alright. So maksudnya volume tu akan sama. So 1.5 lah liter. Calculate the pH of the prepared solution. So bila you dah tahu this is weak base and this is the component of this is the conjugate acid. This is the salt. Ini salt dia. So dalam salt we have the conjugate acid. Sebab nampak tak dia punya component tu ada dekat dalam tu. The component of pyridine. Okay, so you tahu dia adalah buffer. So once you know that it is a buffer solution, and after all dia dah mention kat situ tak mencabar sangat soalan ni Ada soalan yang you tak tahu pun, you sebenarnya kena buat buffer. Okay, soalan-soalan yang macam tu agak tricky. So you have to determine on your own whether is this a buffer or is it a salt ataupun ini adalah weak base. Macam tu. Okay, so tapi soalan makin lama makin senang. Banyak hint yang diberikan lah sekarang. So it will be easier for you to identify whether this is buffer or not. Okay, right. So calculate the pH of the prepared solution. So you pakai Henderson. Okay, find out the pH. Cuba calculate, dapat tak 5.3? Dapat tak 5.3? Calculate Sat. Ayu, ini. Okay, so how is it? Did you guys manage to calculate the pH of the buffer solution? Dapat tak 5.3?
Yes, madam.
Dapat.
Dapat.
Okay,
Dapat.
right.
Dapat, madam.
Dapat.
Okay, cuba ya. Cuba, jangan tak cuba. Tanta, this is the only practice yang you buat before you exam. Manalah tahu nanti kan sakit ke kan, demam ke apa kan. Tapi nak sit for exam. So this is the only time yang you buat practice related to buffer. Kita tak tahu kan. So at least ada that memory kita kutip sikit-sikit masuk dalam otak tu. Okay, alright. So we are going to be using this one, POH. Dia ada dua alternatif You decide you nak pakai mana. So POH is equal to PKB plus log conjugate acid over weak base. Okay, alright. So PKB is not a problem. Dah bagi in terms of KB, you have to negative logkan this value. Okay, 1.52 times 10 to the power of negative 9. And then how about conjugate acid? Okay, so kalau pada saya, dia dah bagi in terms of mole kan. You boleh go for concentration. You can also go for mole. Boleh, doesn't matter. Okay, kalau you nak go for mole, this one is the conjugate acid, the salt kan. So this one should be 0.15 mole. This one, ini dia bagi dalam molarity dengan 1.5 liter, betul tak? So you kena korek, you kena extract out the mole. Okay, alright. So 1.5 liter times 0.125 mole over 1 liter. Okay, dimensional analysis guys. Okay, tekan, you akan dapat the value lah. Nak tekan juga calculator 1.5 darab 0.125. Okay, it's 0. Betul tak ni? 1875 mole. Okay, if you decide to use mole, kalau you tak nak guna mole, that means you kena instead this one you boleh pakai. Okay, alternatively you kena 0.1 conjugate acid, right? 0.15 mole. You don't divide by, atas ni you kena divide by 1.5 liter. Okay, bawah ni value dia you boleh pakai 0.125 molar. Okay, sebab ni you nak cari molar dia, berapa molarity dia. Ni kalau you decide to go for concentration. Okay, this one you boleh pakai 0.125 molar. Sebab the volume for this conjugate acid is not given to us. So kita assume that the volume is still 1.5 liter. And for 1.5 liter, this is the concentration. Okay, alright. So dapatkan POH. Don't forget that pH is equal to 14 minus POH. Okay, that is for A. How about B? Write an appropriate equation to show the effect on the equilibrium if 0.15 mole of HBr is added into that solution. Soalan tanya apa ni? An appropriate equation to show the effect. Appropriate equation je lah kan? Okay, so HBr is added into the solution. So HBr is an acid. Memanglah selalu kita guna HCl kan? Tapi HBr is also strong acid. Okay, it also supplies H3O+. Okay, so when H3O+ is added, acid is added into this buffer solution, siapa yang akan counter attack dia? Yang akan counter attack will be the base. Sebab ini acid, yang counter akan base. So base will be the pyridine lah. Okay, alright. So you kena buat equation. So you kena tahu siapa base sekarang ni sebab nak counter the HBr just now. Ambil kau. Jangan buat macam tu Jangan buat macam tu dalam exam. Mesti kecil. Tambah dengan H3O+. Tak payah tunjuk HBr tu. Buat H3O+. You tahu kalau HBr dia supply H+. H+ we combine with H2O to produce H3O+. Okay, so this H3O+ yang akan cause the pH to be lowered ataupun to reduce. Okay, alright. So dia akan jadi tengok tu lagi sekali. H5N H. Okay, one of the H will be given to the pyridine. So dia akan jadi plus kat sini. Jangan lupa. Okay guys, ni common mistake student buat. Dia tahu tambah and then they forgot the the charge. H2O. There you go for the equation. Okay, alright. Then how about C? Determine whether the pH is raised, lowered or maintained in B. State your reason. Okay, jawapan pertama. Dia ada dua soalan Determine whether the pH is raised, lowered or maintained. Okay guys, what's your answer? Will the pH be lowered, raised ataupun maintained? Apa your answer? Okay, come on guys. Cepat. Kita nak habiskan. Saya nak tutup nak wrap lah ni. What do you think? Kita kena tahu capacity dia kan. So, HBr yang masuk berapa? 0.15 mol. Betul tak? So, berapa pyridine yang ada dalam tu? H3O plus kan? Ya. Berapa pyridine yang ada dalam tu?
0.12.
This one kan? Ni kan? 0.1875 betul tak? Is it? Betul ke?
Ya, betul.
Ya, betul. So, apa jawapannya? Does this H3O plus exceed the capacity of the pyridine of the buffer?
No.
So, apa jawapannya sekarang ni? Raise, lowered or maintain?
Maintain.
Maintain lah. Okay, maintain. Tapi jangan teka-teka maintain lah. Jangan macam tu. You kena ada reason lah. You kena justify. Okay, you have to identify. Okay, so H3O plus yang masuk adalah 0.15. So, kita kena make sure base yang ada nak counter the H3O plus tu should be more than the added acid. So, at the moment, we have this much of base. So, dia still boleh counter dengan bahagianya the H3O plus. So, kalau dia boleh counter, maksudnya it will not be raised drastically. It will not be definitely will not be raised lah. Sebab you masukkan acid kan, dia akan lowered. Tapi is it drastically lowered ataupun dia gradually lowered ataupun reduce? Maintain lah. Maintain tu maksudnya gradually. Okay, dia turun tapi dia still boleh maintain sikit-sikit je point something saja. So the answer will be maintain. Jawab dulu soalan pertama. Okay, and then state your reason. Because dia tak exceed the capacity. Okay, ataupun you boleh cakap this one. The mole of pyridine. Yang sama waktu dengannya lah. Is more than mole of HB. That's all. So that's why it can be maintained. Okay, kita tengok jawapan. This is the answer for A. This one is for B. Okay, C, NH plus, H2O. This is for, yeah, terbalik pula So dia duduk, so dia less. Okay, so this is the habis.
Madam.
Ya.
Yang B tu kan kalau saya buat tambah H plus bukan H3O plus.
Kalau you tambah H plus, so you pergi kat
Tak ada H2O.
C5H5N, you tambah H plus kan, so dia jadi ada satu produk dia, betul tak? Dia C5H5N H plus. You kena dapat ini confirm lah. You dapat macam ni ke ataupun you ada tiba-tiba ada dua produk pula? Dapat this one only?
Dapat tu je.
Kalau tu kita boleh consider lah. Okay, kita boleh consider. Tapi itulah. Kita kan selama ni kita memang pakai H3O plus. Kan? Try to maintain lah. Okay, nanti kejap pakai H plus, kejap pakai H2O. So yang mana yang sebenarnya saya tak sempat nak betulkan yang mana pakai H plus tu semua kalau ikutkan saya nak ganti dengan H2O. H3O plus. Supaya dia standardized. Nanti you tak pening. Kejap lagi kita nak pakai H+, kejap lagi nak pakai H2O+, H3O+. Okay, kalau you tak pening, then it's okay. Kalau you pening, then better stick to one. Then go for H2O+. Because that is what actually happen in a solution. H+ cannot stand alone because they're unstable. It tend to react with H2O to form H3O+. Okay, kalau tak pening, tak ada masalah. Go ahead. Okay, any other question, guys?
Madam,
Yeah.
kalau ratio mol tu bawah daripada 0.1, pH tu dia akan lower
Ratio mol. Yeah. Katakanlah kan, this one is 0.1875. Dia less than 0.15. Katalah dia 0.1 kata. So the pH will be lowered. Sebenarnya kena cakap drastically. Okay, will decrease significantly ataupun drastically ke, menunjukkan dia jatuh mendadak tu. Okay, sebenarnya maintain ni bukanlah maintain initially dia 8 and then lepas letak asid dia still 8. No, bukan. Dia initially dia 8. Okay, bila dah letak asid dia akan turun sikit. 7.9. Letak lagi asid 7.89. Letak lagi asid 7.7. Tak adalah dia 8. Letak asid, jatuh 2. Okay, itulah maksudnya kebolehan buffer. Maksudnya maintain, it has the ability to maintain the pH. So dia jangan lebih daripada kalau this one is less than 0.15, definitely the pH will be lower. This is with subject to H3O+. Kalau OH- yang masuk, dia opposite. Dia the other way around. Okay? Right. Lagi? Any question? Any other question?